can't figure out how to do this. I wonder if there's anything on YouTube that might help me. Maybe there's a video or something? Equilibrium in 2 dimensions. ES226 Statics Video Project. That's my exact class. Maybe somebody did a project on it that could help me. Look at this. Equilibrium in 2 dimensions.
Why, hello there. Don't be disgruntled. You can do it. Understanding how to solve two-dimensional equilibrium problems is an essential step in mastering the science of engineering statics.
Solving equilibrium problems can be condensed into a two-step process. First, draw a free body diagram. Once you have completed your free body diagram, use your friendly equilibrium equations to solve for unknowns in your system.
However, before we can practice drawing free body diagrams and solving our equilibrium problems, we must first understand a bit about support reactions. Support reactions are forces acting on a body that prevent the body from horizontal or vertical translation or rotation.
Let's look at and define some support reactions found in the world around us.
There are many different types of support reactions. Rollers prevent translation in only one direction. In this example, the wheels on the computer table support the table vertically, but the table is free to move horizontally in the direction parallel to the surface.
We also have smooth contacting surfaces. Smooth contacting surfaces act in one direction, perpendicular to the surface of contact.
Another type of support reactions includes pins and hinges. These supports prevent horizontal and vertical translation, but not rotation. For example, when a force acts on this door, the door rotates about an axis through the hinges.
Fixed reactions prevent horizontal and vertical translation and rotation.
There are many other types of support reactions also.
Now that you understand support reactions, follow these simple steps to solve a free body diagram. First, draw the outline of the body. Then, show all external forces, including applied loads, support reactions, and the weight of the body. The last step in your free body diagram is labeling loads and dimensions.
Recall the 3 equations of equilibrium. The sum of the forces in the x equals 0, the sum of the forces in the y equals 0, and the sum of the moments around any given point equals 0.
With this knowledge, you should be able to solve two-dimensional equilibrium problems.
Good luck!
So now I gotta try to do this problem. Determine the magnitude of the reactions at A and B. Well, first, I should probably figure out what the reactions are. So this is a pin, so I guess that's going to stop translation in the x and y directions. So I'm going to say it has AY here, and it has AX there. AX. And this is a roller, so it should only prevent translation in the y direction. So we'll make that BY. Okay. Now let's solve for AX first, because that looks like it's going to be the easiest. So I'm going to do the sum of the forces in the x direction equals 0, and that's going to be AX minus 400 sine of 15 degrees. So that means that AX equals 400 sine of 15 degrees, and so AX is equal to 400 sine of 15, 103.5. So we'll round up to 104. AX is equal to 104 newtons. Okay. So now why don't we do the sum of the moments so that we can cancel out one of these unknown y components. I think that would be the next best move. So we'll do the sum of the moments about A equals 0, equal, our first one is 600 newtons, 4 meters in, and clockwise. So I'm going to define this as the positive direction, so that's going to be negative. So negative 600 newtons times 4 meters minus, this one's going to be negative 2, so this is 400 cosine of 15 minus 400 cosine 15 times 12 meters. And then it looks like we're also going to have to add in by, so this one's going to be positive. we're going to do plus By times 12 meters, it looks like. Right? So then if we solve that for By, we should get By is equal to 600 times 4 plus 400 cosine 15 times 12 all over 12. And this should give us units of newtons, because this is 600 newtons times 4 meters, and this is 400 cosine 15 newtons times 12 meters all over meters, so the meters are going to get canceled, leaving us with newtons. Right, so why don't we plug this into a calculator, and we're going to find that By is equal to 586 newtons. Alright, so that's our second force. So now we only need to get Ay. So why don't we do the sum of the forces in the y direction equals 0. And that's equal to Ay plus By, which we can see is 586 newtons. So why don't we substitute that in? And then we have minus 600 and minus 400 cosine of 15. So minus 600 minus 400 cosine of 15. So now this is going to mean that Ay is equal to 600 plus 400 cosine of 15 minus 586. Now let's go to our calculator and find that Ay is equal to 400 newtons. Okay, so let's see, we have Ax, we have Ay, and we have By. Awesome! I was able to solve a problem involving equilibrium in 2 dimensions, and I was able to find the support reactions. Nice!